Okay, hello. We're going to go through 3.10, the Lagrange multiplier. I'm Noah, and I'm going to be showing you how to go around one of these problems. So let's just go through the steps real quick. We're going to have a f of x plus y, and we're going to have constraints. So in this example over here, our f of x plus y equals x squared plus y squared, and our constraint is x plus 2y minus 5 equals 0. So the first step that we're going to do is we're going to subtract the function f of x plus y by lambda times the constraint. After that, we're going to use this new function and we're going to find the partial derivatives of x, y, and lambda. We're going to solve for x and y in terms of lambda, and then substitute that into the last partial to get x and y to find them. So let's go through it real quick. So first thing we're going to do is we're going to set x squared plus y squared, and we're going to subtract it by lambda times x plus 2y minus 5. So when you distribute that, let me just go back real quick. Okay. Okay, so when we go back, we will get minus lambda x plus, oh no, not plus, minus 2 lambda y, and then minus plus 5 lambda. Okay, be careful with your signs. So with this, we're going to take the partial derivatives of x, y, and lambda. So for x, when you take the partial derivative of all this, you're going to get 2x minus lambda, since it's minus lambda x over here, the x disappears. For y, similarly, it's going to be 2y minus 2 lambda. And for f of lambda, you're going to get minus x minus 2y plus 5. So we're going to set them all equal to 0. And let's quickly figure out what x is. So if we solve for x, we're going to subtract lambda over to the other side and then divide by 2. So it's going to be x equals lambda. Okay. So it's going to be lambda over 2. Y is going to equal, so since we're subtracting negative 2 lambda over and then divided by 2, it's just going to be lambda. The 2's cancel out. So with these two, we're going to plug these x and y into the lambda partial. So we're going to get negative lambda over 2 minus 2 lambda plus 5 equals 0. So now if we solve for lambda, so let's make this over 2, make this a 4. So negative lambda minus 4 lambda over 2 is negative 5 lambda over 2. And let's subtract that 5 over. And then if we multiply both sides by 2 over negative 5, this will cancel, and then this will become a 2. So we're going to get lambda equals 2. So if we plug that in up here to the x value, x equals lambda divided by 2. But now since we know that lambda equals 2, since it's all proportionate, let's do x equals 1, because 2 over 2 is 1, and then lambda equals y, so it will be y equals 2. So when we plug it into our original function up here, we're going to get f of, instead of x plus y, it'll be 1 plus 2 equals, and let's see, we have 1 squared plus 2 squared, so that'll be 5. So that's going to be our relative minimum for this problem. Hope you enjoyed, and I hope you understood.